Hey guys, Mr. Palmer here with another practice concentration problem. Again, we're talking about measures of solution concentration, and there are several. These are the four that we're going to be looking at. These are probably the most important ones you're going to experience in chemistry. So let's look at a second sample question. This one asks you to determine the molarity, molality, and mole fraction of concentrated hydrochloric acid. This is the way it would be shipped to you. Generally, we dilute it. It has a density of 1.19 grams per cubic centimeter, so it's giving us the density of the solution, and a mass percent of 38. So it's telling us one of the solution concentrations, and we're going to convert to the other concentrations, working with that percent. Again, it's important to go into what the definitions are. If you can remember what the definitions of these concentration units are, it's going to really help you in the long run. So let's start with the molarity. We're going to be finding the moles of solute per liter of solution. So let's just set up what we have. We know the mass percent is 38 grams, right, or 38%. So that's grams per mass of solution. So what's the total mass of solution? Well, it would be 38 out of 100. And we want to get that to be moles of solute over liters of solution. So let's first start and tackle the concentration, or the mole part. So for hydrochloric acid, it has a molar mass of 36.46 grams for every 1 mole. All right, we've got that part taken care of. And now we've got to deal with the solution part. It's per 100 grams of solution, but we want this to be per liter of solution. So we were given the density up here as the 1.19 grams. So we can say that there are 1.19 grams of our solution in every 1 cubic centimeter, that is every 1 milliliter. But again, we don't want this to be in milliliters, we want this to be in liters, so we know that there are 1,000 milliliters in every 1 liter. So if you look back, our milliliters are going to cancel. This is our grams of solution are going to cancel, and our grams of HCl are going to cancel, leaving us with moles of hydrochloric acid per liter. If you do the math here, this comes out to be 12.4, and that is really the most concentrated HCl you can get, and that's the way they ship it to us. So we kind of dilute it from there, whatever we're given. Let's take a look at the molality. All right, let's try that. So again, this is moles of solute per kilogram of solvent. So this one is a little bit of a trick here. We can start out the same way and say we have 38 grams of hydrochloric acid, but we don't want liters of solution. We want kilograms of solvent. So let's think about that. If we have 38 grams of hydrochloric acid and our solvent is water, that means that there are 62 grams of water in that same amount of solution. For every 38 grams of hydrochloric acid, you have 62 grams of water. We can convert the moles very much the way we did before. This is 36.46 grams of HCl for every 1 mole of hydrochloric acid. And now we just need to convert the water. Well, we know the density of water. We're going to use 1 gram per milliliter. Actually, I'm sorry. We don't go to 100 grams. We just want to go to kilograms, right? I'm sorry. So that's 1,000 grams in every 1 kilogram. So it's a little bit easier than doing the molality. And if we look back, the grams of water cancel grams of water, grams of HCl cancel grams of HCl, and we're left with moles per kilogram. And again, this gives you a larger molality than your molarity, 16.8 molal. Little m, that's for molal. Mole fraction, again, moles of whatever it is we're looking for over the moles total, which means we're going to have to calculate the moles of hydrochloric acid. We're given 38 grams of it, 36.46 grams per mole. If we do that, that gives us 1.04 moles of HCl. And we need the moles of water. Well, for the last problem, we know that the water was 62 grams. And water's molar mass is 18.02, which is going to give us 3.44 moles of water. So going back to our definition, remember it's moles of the thing that we're looking for, moles of the HCl over the moles total. So we're going to say, all right, 1.04 moles of HCl, and the total moles are going to be 1.04 plus the water, which is 3.44 moles of water. And again, we don't multiply by 100 or anything. This is the mole fraction. So the mole fraction of the HCl is going to be 0.232. If we subtract that from 1, that will give us the mole fraction of the water, which is going to be 0.768. Okay, and the last part of this, let's take a look, and this is pretty common. What if we wanted to determine the volume of concentrated HCl required to make 2 liters of a 0.25 molar solution? That's calculating concentration using dilution. So the equation that we use for that is M1V1 equals M2V2, in which concentration times the volume is going to give us moles. This is the moles of solute, and when we dilute, the moles of solute stay the same because we're just adding solvent. So we've already calculated that the molarity of this solution, the HCl concentrated, was 12.4. And we're trying to find the volume of it, that's our V1. And we want to make 2 liters of a 0.25 molar solution. So 0.25, and we want to make 2 liters of it. We do our math, we get 0.0403 liters, which is going to be 40.3 milliliters. You would need to take that and dilute it to a total volume of 2 liters using a volumetric flask. So if the question asks you how you would go about doing that, you would want to talk about the what would you use to measure the volume, maybe a burette for the concentrated acid or a pipette of some kind, and then diluting it in a volumetric flask to a total volume of 2 liters. Alright guys, thanks, and I'll see you on the next one.